Hi, I am Zeyu from the University of Maryland. On behalf of all authors, I present you SolderlessPCB, reusing electronic components in PCB prototyping through detachable 3D printed housings. In the conventional PCB prototyping process, components and the circuit board are acquired separately and soldered together to form a complete functional assembly. These PCB assemblies are one-off creations. When errors occur in the PCB or when they're no longer needed, the electronic components are often not disassembled for reusing, even if they're perfectly functional. In SolderlessPCB, we propose a revised approach to assemble SMD components to circuit boards with a custom 3D printed housing. In turn, it doesn't require desoldering to disassemble components from the board, so that they can be easily reused in further iterations or other projects. Here is an example of reusing electronic components using our technique. This is a solderless kitchen timer that utilizes 2 push buttons, 2 7-segment LED displays, an ATtiny 828 IC, and a coin cell battery. These components are assembled to a custom PCB by a bolt-on 3D printed housing. To reuse these components for a different prototype, we can simply unscrew the nuts to separate the PCB and the housing. Take the components out of the housing. Reload them in a different housing design for a football scoreboard. And bolt it onto the matching PCB to form the assembly that reuses the component from the original kitchen timer prototype. Once the new code is uploaded, the components are fully repurposed for a different application. With SolderlessPCB, we can also reuse components between design iterations. For example, in this clip, the first iteration of a bristle bot contains an ATtiny 84 IC and 2 GSC connectors. To make it more fun to play with, we can add several more components while reusing the original ones in the first version. With an additional onboard ambient light sensor and a buzzer, the robot now reacts to ambient light and makes a high-pitched sound when moving. The solderless assembly technique draws solid electrical connection between boards and the components. It can afford high current applications like this mug heater that reaches 45 degrees Celsius within a minute, while about 3.3 amps of current travels through the solderless connection points. Solderless PCBs are also reliable for serial communication. For example, a solderless FTDI unit can smoothly upload code to development boards that do not have a USB connector. It also supports high-frequency data transmission. For example, data can be sent through solderless connections from an IC to an OLED display through I2C communication. To make sure that the solderless PCB assembly technique is generalizable to different SMD packages, we tested our method on ICs of different form factor, including QFN, TSSOP, TQFP, SOIC, and even small BGA packages. The firm bolt-based assemblies are also prone to mechanical impact. The technique can also be implemented with different housing manufacturing techniques and materials, such as FDM printed PLA or CNC milled MDF. They also work well with both homemade copper clad or outsourced plated PCBs. In all, we present solderless PCB, a PCB assembly technique with detachable 3D printed housing that helps promote electronic component reuse. Thanks for listening.